And at this point, I will hand over to Jason, because Jason, we actually heard about Jason and the great work he's doing at Nvidia through an interaction with the Intellectual Property Office. And Jason's company, Nvidia, is a technology provider that I think is really helping people to think about the future in very different ways.
Trying to.
And you don't need this, do you?
I do not need the clicker, because I've been stealing everybody else's content.
So thank you very much, Jason. Not John or Mark.
No, and it looks like I'm standing in the right place. So, good morning, everybody. My name is Jason Southern. I work for Nvidia. So we talk about things quite a lot that don't physically exist. We talk about virtual technologies, or the leveraging of virtual technologies to create physical things. Just out of interest, how many people in the room have started their career in engineering or manufacturing when it was just paper that we were working from? So you've already seen the change of moving to a digital working environment, some people in the room. And I think we're on the cusp of moving into a new direction now, of taking those digital technologies and connecting them together and connecting the solutions that they provide. Instead of working on a CAD model and then passing it to somebody that does material modeling or fluid dynamics with it and then passing it to somebody else, we're moving to the world of digital twins, which go beyond just physically representing a single item. We're bringing those solutions together and we're allowing them to interact at the same time and allowing them to work together. So this is one of the strengths of digital twins and the technologies that we have today. Digital twin is not a new technology. It's been around for decades. And it means different things to different people. To a CAD designer, to somebody that's creating a physical object, it's a representation of that object. It's what we see in the virtuality. It could be just a three-dimensional model. To somebody else who's manufacturing a turbine, somebody like Rolls-Royce, it's the amount of data that they are capturing to represent the behavior of that at the same time. Where we're coming to now is the ability to bring those things together. Can we bring the three-dimensional model of that turbine, or of that vehicle, or of that kettle or toaster, and bring them together with the data and the sensor data that we capture and make it visible to people who are working with it and to allow us to interact with that. So we have the visual representation of the real world in a virtuality, in a virtual environment. This is the direction that our digital twins are going today. And there are lots of organizations that are already starting on this path, and lots of people that are thinking about it and getting ready to go in that direction. But the potential it brings us is substantial, because as we think about it, we start with a single object, which is a digital twin of, let's take that turbine. We have that turbine, and we know how that's working, and we know now we've got the sensor data, we're capturing that, we're seeing how the components in there are being affected by use and wear. In the past, this has always been done by, well, we know they'll run for a certain period of time, and then we have to replace them whether they're broken or not. And sometimes they fail earlier and sometimes they fail later. Now we get real-time data of what's happening. We can better predict where we need to place our resources to repair them. Better predict where we need to place the resources to manufacture those replacement components. And it's interesting, there was a question earlier on about distributed manufacturing, is that I think we're starting to open the doors now of knowing where we need things allows us to then move manufacturing to where we need them, as opposed to where manufacturing is traditionally. So it's an opportunity for us to do this, but we can scale up this and we can leverage this information and all of this sensor data we gather, because I think every single person in this room is gathering data now about themselves and sharing it, sometimes without even realizing it. The things that we have in our pockets or in our bags that are gathering data about where we go and what we do. The same is happening in cars, in buses, in trains, in planes, in toasters, in refrigerators. It's all coming together. So can we use this information? Can we use this information to better plan for the future? I believe we can. Just making sure I'm standing in the right place, because I do tend to drift. Can we use this information to better predict our future? Yes, we can. And it's interesting the mention of things work well until we interfere with them, until we get involved with them. We make a prediction, we make a plan, this is a fantastic plan, let's follow it, and then we go, oh, I'm just going to change something. And that iterates back into the manufacturing process. But often those insights are very valuable, but the human capacity to do this is limited. We have to sleep, we have to eat, we have to do many, many other things. And often we disagree on how to approach it. And this is where we start to combine the concepts and the ideas of AI. And again, AI is not a new concept. The frameworks, the tools, the algorithms that we're using today are decades old. It's just now we have the means to be able to leverage them. We have the data, we have the horsepower in our data centers and the power to be able to utilize that information. So we can bring this together. So we start combining these digital twins. We start combining the sensor data we've captured about the things that we've designed and built. And then we start applying AI to how we can improve them. Can we improve the resilience of this? By changing a material, can we improve the resilience of it? By changing the load level on a system, can we improve it? Actually, are we understressing a system? And I think many of us know that we can understress a system and put load on a system by not using it in its optimal manner. Whether that be supply chain, whether it be a vehicle, whether it be a boat, a plane, a train, a toaster, a fridge. Because if we don't fill our freezers up, they become inefficient. You know, there's an example that we can use today. So can we use this data? Can we use an artificial intelligence to very, very rapidly assess the information and assess the data that we're doing and represent that back in a digital twin that we, as humans, because we're visual individuals, can see? And we can see the impact and we can see the benefits. This is the opportunities that we're starting to see today. And as we start bringing in robotics and self-driving and autonomous vehicles, whether they be cars or trains and autonomous trains, how do we optimize those systems? How do we make them better? But not just that, how do we make sure that they are safe? If we build something and it's going to move under the power of software and be driven under the power of software, we need to make sure that's safe. We need to make sure that we can trust the software. And how do we do that? We simulate. How do we simulate? We take the digital twin, exactly the same model that we designed and we were prepared to ship out to a dealership or ship out to a train station and put on a track and test it. And we test it. And we simulate that testing over and over and over and over again. And the beauty of a digital twin is we can change the weather. We can change the heat. Our recent heat wave in the UK threw our rail system into panic because it's designed to operate within a temperature range and it got hotter. If we have a system where we can predict those, we can plan better for it and plan better for what we manufacture and plan better for what we build. Of course, if we went to Saudi Arabia, their train rail system is designed around a completely different thermal range. So it's different. They're never going to deal with -5, -6, -10 in their environments, but they are going to deal with +50. We have a problem where our range is -10 to +35, and we certainly went over that over this summer. So how can we optimize, how can we test our systems and stress test our systems on our environments? How can we bring this information together and get the information that we have we're gathering from the field, we're gathering from our environments and build it into the manufacturing process? And this is the opportunity that digital twins bring to us. It's the opportunity that AI brings to us. And it's also the opportunity that the concept of the metaverse brings. Now, the metaverse means many things to many people, but in a simple term for myself, it is connections of virtual worlds. It's virtual environments that we can bring together. There will not be one metaverse. There will be many. Every manufacturing organization, every industry will have a metaverse in which they test things and they develop things and they trial things. And different organizations and different departments within an organization and different suppliers within a manufacturing chain will be able to come together and work on this. And it's the opportunity for us to optimize our supply chains, optimize our development and workflow, to go from design through to build and then to operate, but also to market. If we bring all those skills with the marketing departments and the visual departments together and allow them to work with the same tools and the same assets and interact with the designers and the manufacturers from day one, we get a much better outcome. Everybody is working on the same thing from day one. People aren't waiting for a change to be made, to be passed down, for them to go, we can't build this and send it back. We can't sell this because you haven't finished building it yet. And that's the same whether it's a car, a plane, a train, a fridge, a shoe, a jacket, whatever it is. by being able to iterate and be able to interact at various stages, all these different departments, we can really enhance and optimize our world. And the last thing just to touch on there as well is that also allows us to capture talent where talent resides. Leveling up this morning, the first thing that when I came in was being talked about. It's hugely important to me. I think I've benefited over the last decades of benefiting from leveling up. I started out at the bottom, I didn't go to university, and I've worked my way up and through, and I've had various opportunities throughout. And I think I've been lucky, and I think we need to bring that to others. And I think the virtual environment, remote working, flexible working, virtual environments, and being able to collaborate remotely brings great opportunity to people that maybe can't afford to live in London, maybe can't afford to move to the key cities where today we expect them to be to work. It brings opportunity. There is value, huge value in physically being together, but there's also huge value in capturing talent where talent resides. And that, I think, is an opportunity for us. I think that is an opportunity that digital twins, AI, and the Metaverse can bring to us in manufacturing industry today. Thank you.
Thanks, Jason.
Did I overrun? I'm sorry.
No, you were perfect.
I do tend to ramble.
No, you didn't. You were absolutely perfect.
Thank you.
Are there any questions for Jason? Yes.
Sorry.
I just wondered when you spoke about systems interacting, how you had a vision of them doing that.
So systems as in physical mechanical systems, or systems as in supply chain systems, or all of the above? So I think if we look at physical systems, and if we look at design systems as well, it's about standardization, and standardization in protocol and communication standards are hugely important to us. And I think that the standards, whilst some people will say that standards limit us in what we can do, it also helps us to develop and grow interaction and work together as people. That's what language is. Language is a means by which we can communicate. And if we have that language at systems level, that helps us do that. So I think standards and standardization and interconnectivity at that level, at a technology level, is hugely important. When we level up when we come up a level or down a tier, whichever direction you want to go, if you're talking about supply chains, that's very much a contractual, legal construct that has to allow for these interconnected communications. And one of the previous speakers talking about how we interconnect those supply chains and make them communicate better, I think that is a step we have to take, and we have to take them through. And different cultures, different legal entities, different states have different rules about how we can share information and share data. So that is potentially a challenge for us, but it's also an opportunity for us as well to find better ways to interact together. Okay. And people, we need to talk. We need to talk to each other. So I think we've found that over the last couple of years, in a pandemic where we've all been locked away, we still continue to communicate. And those organisations and those people that still continue to communicate, still continue to be creative, will still be able to be productive. So communication is key at a human level, at a systems level, at a supply chain level as well.
Sorry, the lady just behind Len.
Thank you for your presentation. I just wondered, in my understanding, we can only model what we know.
Yes.
So if there is some unknown we don't know, can AI predict that? Can AI bring that to us? How do we?
That's a good question. I think the honest answer has to be, I don't know, because it's an unknown. Can we attempt to predict everything? No, because there will always be an edge case or a side case. But I think we have had organisations that have gone through similar processes and have identified that something they had never considered is very relevant in their design. And without naming the organisation, there is a large supermarket in the UK, based in the UK, who is now using digital twins and AI to reassess their store design. And they came out with something that nobody in the room had actually considered of why are we putting so many hot lights in this building and then putting a row of refrigerators in to cool the place down and air conditioning it. If we change the lighting, which we hadn't even given a thought to, if we change the lighting, our energy profile changes massively. And that's just become hugely, they looked at this months ago, and that's become hugely important. But it was an edge case that nobody had actually considered because, well, we've always done it this way. Let's keep doing it this way. So I think there are known unknowns that we don't consider because we've always done it that way as well. So can it help us? I think it can, yes, and it will. And as we refine it, we will get better. And this is where it's been used in medical as well, very, very much. And I think if you look at kind of iterative design and almost organic design, where AI is applied, you look at what it's built and you go, that looks bizarre. It looks like it's grown, not built. And yet you put it through the testing and the stress testing, etc., and it actually comes out far superior to what we've done previously. So I think sometimes, yes, it can help us. Sometimes its outcome will be a little strange, or strange to our eyes because of what we're used to in the past. But hopefully, yes.
So I think there's 2 more questions, but what I'm going to suggest that you do is hook up with Jason over coffee, because I'm trying to keep us to time, not one of my strengths, along with names.
Nor mine, by the way.
So can we just thank Jason?
Thank you, everybody.
That was great. And I'd suggest to find out more about what Nvidia does to